In this video, we're going to create some Bootstrap confidence intervals, and the mechanism that we're going to do that is using the lapply function in R. So in general, a confidence interval procedure produces plausible values for a target parameter with an associated level of confidence. And the idea is that if we repeatedly obtain samples from a population, a confidence interval procedure is going to produce intervals containing the target parameter with probability equal to the confidence level. However, a weakness of confidence interval procedures is that oftentimes they assume that we know the population distribution from which the sample came, which is oftentimes not the case. A Bootstrap confidence interval procedure can be used to construct confidence intervals when the population distribution is unknown. More generally, the Bootstrap method allows us to approximate the sampling distribution of a statistic by using the observed data to produce simulated data sets. So let's say we have a sample of n data values x1 up to xn, and let's say we want to estimate the population mean mu from which the sample came. Well, a natural estimator of the population mean is the sample mean, x bar. So let's talk about the procedure for producing a Bootstrap confidence interval from mu with confidence level 1 minus alpha. So the first thing we have to do is create a Bootstrap sample, which is obtaining a sample with replacement of size n from our observed data values. For each one of those random samples that we obtain, we're going to compute x bar, that's the sample mean of our Bootstrap sample, and then we repeat steps 1 and 2 a whole bunch of times. So specifically, we're going to say we do it b times, where b is some large number like 1,000 or 10,000 or something like that. And once you get your large number of statistics from your Bootstrap samples, you can obtain the alpha over 2 and 1 minus alpha over 2 quantiles of your sample means in order to get your Bootstrap confidence interval. So let's say we have observed the following sample, 3.318, 4.940, all the way up to 1.884. Let's create a 95% Bootstrap confidence interval for the population mean from which that sample came. We're going to build our function based on lapply. Our function is only going to take 3 arguments. It's going to take x, which is a vector of numeric values. It's going to take conf.level, which is the confidence level desired for our confidence interval. The default value is going to be 0.95. And it's also going to take b, which is the number of Bootstrap samples we want to use to build our confidence interval with. And the default value is going to be 1,000. Here is our Bootstrap confidence interval function, bootstrap underscore ci. So we define our function here, and it takes 3 arguments, x, conf.level, and b. As previously mentioned, the default value for conf.level is 0.95, and for b is 1,000. The first thing that we want to do in our Bootstrap confidence interval function is determine what alpha should be, and it's simply going to be 1 minus conf.level. The next thing we're going to do is we're going to use the lapply function to obtain Bootstrap samples and then compute the sample means of each one of those Bootstrap samples. So I'm going to apply the lapply function to each value in the vector 1 up to b, and then I'm going to take that value and I'm going to plug it into an anonymous function, which is what I have here. So at this point, we've typically just plugged in a function here, but we're actually inventing a function on the fly. This is called an anonymous function because we're not even defining it ahead of time. And so our function doesn't have a name, which is okay here, but our function takes the value I from this vector over here. And then the first thing that anonymous function does is it samples from our vector x in values with replacement. And so that's going to create our single Bootstrap sample, and we assign that the name boot underscore sample. And then once I have my Bootstrap sample, I'm going to compute the sample mean, which is what is going to be returned by my anonymous function. So essentially what's going to happen here is for each value of I between 1 and b, I am going to draw a Bootstrap sample and compute the sample mean and then return the sample mean. And that's going to be stored. All those sample means for my Bootstrap samples are going to be restored in bstats. And because I'm using the lapply function, that's going to be returned as a list. I'm going to use the unlist function to convert my list to a vector. And I'm going to give it the same name, bstats. Now once I have my bstats vector, I'm going to supply that to the quantile function, and I'm going to compute the alpha over 2 and 1 minus alpha over 2 quantiles. And that's going to be how I compute my Bootstrap confidence interval from a sample supplied to this function. So let's enter this function into R's memory. And now I'm actually going to apply our function to the observed data. I'm going to set the number seed to 43 so that we get reproducible results. I'm going to create this vector x, which is just a vector containing the values that we previously indicated up here. So I create that vector, and then I'm going to put that vector into my bootstrap underscore CI function. And when I do that, I see that the lower bound is 2.44 and the upper bound is 4.98. What that means is that our 95% bootstrap confidence interval for the population mean is 2.44 up to 4.98. And I didn't tell you this, but our sample was actually just a random sample from a normal distribution with mean 3 and standard deviation 2. So our interval, in this case, actually did contain the true value.